Well, good morning, afternoon, or evening, everybody. Welcome to the Expand Your View of Earth with NASA Worldview ESDIS Data Training webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we're going to go ahead and get started here. And what I'll do first is begin today's webinar with just a few logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A panel rather than the chat, and you should see this on the right side of your screen. If you don't see the Q&A panel, then you can click on the three dots at the bottom right of your screen, and that should pull up your panel options, and then you can insert a check mark next to the Q&A panel. Today's webinar is being recorded. The recording will be posted to our NASA Earth Data YouTube channel within a week of completion. Once completed, I will send an email to all registrants and participants that includes links to both the recording and presentation slide deck used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations and an additional 15-minute question and answer period to begin after the presentation. Depending on the volume of questions we receive, we may extend the Q&A session, but we will have a hard cutoff of 3:15 p.m. Eastern Time. During today's webinar, our speaker is Minnie Wong. Minnie is the systems engineer, and let me actually advance my slides here. All right, Minnie is the systems engineer for the NASA Worldview project within the Earth Science Data and Information System, or ESDIS project at NASA's Goddard Space Flight Center. She will begin today's webinar with an overview of NASA Earth Science missions in ESDIS, and then from there we will transition to an introduction to NASA Worldview, NASA Snapshots, and the Global Imagery Browse Services, or GIBS. From there, we'll highlight the benefits of using Worldview and GIBS, discuss what Worldview and GIBS provide, and describe the key features of NASA Worldview. The second part of her presentation this afternoon is going to focus on some NASA Worldview demonstrations for several recent events. And then finally, Minnie will briefly touch upon a recently released time series charting feature or capability that is currently in beta testing. She will end her presentation with some information about Worldview Imagery Use Guidelines and also some helpful links. And then when Minnie has finished with the presentation, she'll toss it back over to me for a final optional set of polling questions. And then from there, we'll jump directly into the question and answer session. And so before I toss it over to Minnie, I wanted to cover just one final note about the Q&A session. We will try to answer all of the questions within the time allotted, but if we're not able to address your question during the Q&A period, Minnie should be able to follow up with you offline. So with that, it is my pleasure to introduce today's speaker, Minnie Wong. And so Minnie, at this point, I'm going to stop sharing my screen and toss it over to you.
I need to unmute first. Hi, everyone. Thank you, Jennifer, for introducing me. And welcome all of you for attending this webinar. So let me get started and try to share the screen. Make sure, can you all see the screen? All right.
Yes, I can. Thanks, Minnie.
That's great. Thank you very much. So yes, as Jennifer mentioned, my name is Minnie Wong. I work on the NASA Worldview project at NASA Goddard Space Flight Center. So yes, let's get started. As Jennifer mentioned, these are the few things that we'll go over today. So I will go over an overview of NASA Earth Science missions and the Earth Science Data and Information System, talk about what NASA Worldview Snapshots, and GIBS is, and why you should all use it. We'll have some demos and talk about a feature in beta testing, as Jennifer had mentioned. So let's jump right into it. So I will start with an overview of NASA Earth Science missions. As an exploration agency, one of NASA's missions is to know our home, planet Earth. We develop novel tools and techniques for understanding how our planet works for the benefit of humanity. And for insights, we need to explore other moons and planets. In order to study the Earth as a whole system and understand how it's changing, NASA develops and supports a large number of Earth observing missions. These missions provide Earth science researchers and decision makers the necessary data to address key questions and to enhance our understanding of Earth. So NASA, working with international partners, has a fleet of over 20 satellites orbiting the Earth, with sensors taking different measurements and images. NASA also has instruments aboard the International Space Station, like the Global Ecosystems Dynamics Investigation, also known as JEDI, which is about to be relaunched on the ISS next week. We also have airplanes, balloons, ships, and also have measurements taken from on land. So this chart here shows NASA's current and planned Earth observing missions from 2000 to 2030. So as you can see, there are quite a lot of satellites out there and missions planned for the future. Moving on to the next slide. So remotely sensed data comes down into ESDIS from all of those Earth observing missions to distributed active archive centers, which are called DACs, and SIPs, which are science investigator-led processing systems. So as we mentioned before, NASA Earth Science data comes from various sources like satellites, aircraft, field measurements, and much more. And so ESDIS, the Earth Science Data and Information System, is responsible for processing and archiving and disseminating NASA's vast collection of data, which include both near real-time data sets and standard data products that are openly available and accessible online, totaling to almost 130 petabytes. So as I mentioned, the data comes down to ESDIS, to the DACs and SIPs, and then we create data visualizations or imagery. It's produced and archived and served through the global imagery browse services. This then is served out via standardized web services to web mobile clients like Worldview and firms. Some of you may have heard of firms. Whoops. And also you can pull them into your own GIS clients like QGIS or ArcGIS. And also you can be used by scripts and utilities. So Worldview and GIBS provides a visual first approach to finding and using Earth observations. So what is Worldview and Worldview Snapshots? Worldview is our open source web mapping application for users to interact and browse NASA's 1,000 plus global satellite data visualizations within hours of it being acquired, as well as imagery from the past few decades. So Worldview and GIBS provides data visualizations, not the original full precision data. So we provide a connection to Earth Data Search where you can download the original data set. Here are just a few examples of events that we've seen in Worldview. Next, Worldview Snapshots. Worldview Snapshots is actually a low bandwidth, lightweight tool for creating image snapshots in a variety of file formats from a selection of popular NASA satellite imagery base layers and overlays. Worldview Snapshots actually has been particularly useful for users on boats and ships. They've told us that they often only have access to satellite internet connections and prioritize getting simple images for assessing things like storms, sea ice, and much more. Moving on to GIBS. GIBS is the Global Imagery Browse Services. They are standardized web services, also known as APIs, that provide fast and open access to the 1,000 plus global full resolution visualizations of NASA Earth science observations. Many of these products, around 200 of them, are available within 3 to 5 hours after being observed by the satellite. Access is available via web map tile service, tiled web map service, and geospatial data abstraction library. So Worldview and Worldview Snapshots are powered by GIBS. So why would you want to use Worldview and GIBS? You can view and explore the Earth as it is right now, see hurricanes forming, wildfires burning, icebergs drifting, and city lights illuminating. But you can also view changes on the Earth's surface over time using the daily global imagery going back 2 decades. So you can watch cities expand, farmlands grow, and forests change. Worldview provides fast and responsive maps that are highly interactive through space and time. And you can also pick from the 1,000 plus data visualizations that can all be viewed within the same interface. Moving on to what actually Worldview and GIBS provides. So we have imagery in 4 map projections: geographic, Arctic polar stereographic, Antarctic polar stereographic, and Web Mercator. Web Mercator is actually only available via the GIBS API, but you can use it in your own applications if you prefer. Imagery data types include raster and vector, and the spatial resolution of the imagery ranges from 30 meters to 375 meters to 1 degree per pixel. And the temporal resolution ranges from 6 minutes to daily to monthly to yearly and many others in between. And lastly, the latency, which is the time from satellite observation to availability within GIBS and Worldview, is 40 minutes for geostationary satellites. Those are satellites that are basically parked over a certain location of the Earth. 3 hours, which we call near real time for many others, and then longer for everything else. As I mentioned before, Worldview has raster imagery types, and we actually have 2 types of raster imagery. We have opaque base layers, which are often interpreted as is. So like this example here, it's a true color corrected reflectance image from the VIIRS instrument aboard the NOAA 20 satellite. So true color or natural color reflectance imagery would be similar to taking a photograph from the satellite. The other imagery type we have are transparent capable overlays. So these are often images that have color palettes, such as this example here, which is chlorophyll A in the oceans. It's from the OCI instrument aboard the PACE satellite and shows chlorophyll A concentrations in oceans and large bodies of water around the world. Worldview and GIBS also provide vector data, which are static features. So we have points, lines, and polygons that are supported, but we also provide associated metadata or attribute information for user analysis. So in this example, we're showing the fires and thermal anomalies layer from the VIIRS instrument aboard the NOAA 21 satellite. Oh, sorry, actually the NOAA 20 satellite. The fire points, which are these red dots on the map, they represent the center of a 375 meter pixel on the ground. You can, you can actually see the smoke emanating from these fires in the true color reflectance image underneath. So if you actually click on any one of these fire points, you will get an attribute table that shows the metadata attributed related to that point. So we have things like brightness, temperature, fire radiative power, detection confidence, as well as, of course, the latitude and longitude and the time at which it was observed. Next are key features of Worldview. So Worldview is an interactive map to browse and view data visualizations from the past and present. We have features such as tour stories, which help you learn how to use Worldview, how to visualize certain data visualizations, and explore interesting past natural events. We have a layer picker that helps you pick through those 1,000 plus data visualization products we have and are categorized. There's ability to create animations and export to animated GIFs. We also have a comparison tool, which allows users to compare data visualization side by side. We also provide a share and embed feature, which allows users to embed Worldview onto their own web page. I'll talk about that more in a little bit. We also provide a curated listing of events through the NASA Earth Observatory Natural Event Tracker. And as I mentioned before, an option to download the original source data via Earth Data Search. So we will now move on into the live demos. I will, I'll try and turn my camera off if I can to make the internet so bad, but I can't figure out how to turn it off. So maybe I won't do that. So we'll cover flooding in the Midwest US, Midwest and Southeast US that happened just a few weeks ago and is actually probably still flooded now. We'll also talk about the iceberg A63A that grounded near the South Georgia Island in the Antarctic in March 2025, and also go over some imagery about smog over Pakistan in November 2024. All right, so we'll get started with that. Jennifer, can you tell me how to turn the camera off? Maybe you have to just stop sharing.
Let me try this and see if it works here.
All right, thank you.
Hopefully it doesn't stop.
There we go. That works. Okay, hopefully the internet is better now. The demo is going to work better now. So here we'll start introducing Worldview. So Worldview is worldview.earthdata.nasa.gov. So please go visit the site a little bit later. So when you first load Worldview, you get this Welcome to NASA Worldview window. And it shows a list of tour stories that actually help you explore interesting past natural events, like this news story about El Nino impacts around the globe. You can also learn how to visualize certain data visualizations, like the Opera surface water extent or night lights from NASA's Black Marble data product. And we also have an introduction to Worldview tour story that'll show you just what all the elements on the map are. So if you close this window, you can start interacting with the map. But if, say, later on you want to come back and look at those tour stories, you can click on the I button in the upper right corner. And we have a few different options here. So Explore Worldview will bring back that window. We will also have some other global settings where if you have a layer that has temperature in it, you can change it between Kelvin, Celsius, and Fahrenheit. You can also change the coordinate format. The coordinates are actually shown down here. You can also click on this to change it. And also we have an approximate dateline that shows when you are near the edges of the map. Other options we have are notifications. So here we have notification of this webinar right now, and we also have links to our Worldview image of the week, which we post every week. Links to About page, the source code. Worldview is open source, so you can go to GitHub and actually help contribute to Worldview or spin up your own local version of Worldview. You can send us feedback through the feedback module here. And the most helpful thing might be is if you just want to concentrate on the image on the map, you can select distraction free and it gets rid of all of the menus and timeline. To get out of that, you can click on this I button to exit the distraction free mode, or you can use the escape button on your keyboard. All right, so now we'll start with flooding in the Midwest and Southeast US in early April 2025. So a slow-moving storm inundated the Midwest and Southeast US with rain in early April. Some areas experienced 10 to 15 inches, which is 25 to 38 centimeters of rainfall between April 1st and 6th. These rains caused major floods along many tributaries of the Mississippi River, like the Ohio River watershed in Kentucky, Illinois, and Indiana, and along the Black River and White River in Arkansas. So let's go take a look at this event in Worldview. So here we are in Worldview, and you can see actually that today, on April 16th, this Terra satellite hasn't actually passed over most of the US yet. So if you're curious to know when it will, you can click on the View Options button on the right side of the layer you're interested in and add the associated orbit track, which is descending the daytime orbit. You can also add these via the Add Layers button in the lower left corner, the layer list. So here now you can see that these are the satellite orbit track times, and they are reported in Coordinated Universal Time, which is UTC. And so we won't be able to see what's happening in the Southeast and Midwest US because there's no imagery yet. So let's change to yesterday and zoom in to the area that we might be interested in. Even turn on the place labels and see that here we're looking at Kentucky, Indiana, Illinois, this area. And you can see that for this satellite overpass, it happened around 15:19 UTC, which is 10:19 a.m. Central Daylight Time or 11:19 Eastern Daylight Time. So let's look at this image a bit more. I'm going to turn off the orbit track so we can see the map a bit better. And let's use the search for places or by location box in the upper right corner. And I'm going to type in Evansville, Indiana. Click on that and the map will zoom to the area. So Evansville, actually the floodwaters here reached the highest level it has since 1964, which is 61 years ago. And it crested at 47.67 feet on Saturday, 12th of April. So in this true color image, you can kind of see kind of vaguely very brown areas here, and this is actually the flooded area. But it's kind of hard to see, so let's try to change this to a more cloud-free day. Using the arrow buttons in the lower left corner, we can decrement the date, and April 14th is still cloudy. April 13th, it's a little bit less cloudy, so you can kind of see the river a little bit more clearly, but it's still pretty hard to see. So let's add another layer that will better highlight the floodwaters. So I'm going to go to the Add Layers button down here in the lower left corner of the layer list. And as I mentioned before, to be able to search through these 1,000 plus data visualizations, we have split up the data visualization layers by hazards and disasters and science disciplines. And there are also some featured layers. So this will just make it easier for users to find the data they want to find. So what I'm going to do is add a corrected reflectance layer from the Terra satellite, because that's what we're looking at right now. And we are going to add the corrected reflectance band 721. And over here in the layer description on the right of this window, we can scroll down and just see what's so good about the band 721 image. So this false color image actually does say right here, it's useful for distinguishing burn scars, but also for enhancing floods. So now that we've added that, we can exit out of that window. And now you can really see the flood waters in blue, vegetation's green. And this looks pretty flooded, but if you want, we can also add another more helpful layer, which is the flood product. So we'll go back to add layers and click on flood and look at the Terra and Aqua Modus flood 3-day window product. So this layer, you can see it right here. It's provides a daily global map of flooding, and for the 3-day window, it composites all observations from MODIS on both the Terra and Aqua satellites over a 3-day period. So we'll close that. And here now we can really see, so the flooded areas are shown in red, and the regular river course is in this cyan blue. So it's quite a lot of flooding. We are now going to change the date to April 11th, just to show you another thing with this data product. If it's very cloudy, it won't be able to find any data. So now you can't really see that many of the red flood pixels. Instead, it's covered by this gray insufficient data value. So let's turn that off by going to the View Options button and turning off the insufficient data classification. And now what you can see is, the reason why we can't see the floods is because the clouds are blocking our view. So this day is not so useful, so we'll go back to April 13th. All right. So maybe we're interested in measuring the width of this flooded area right here. We can go to the ruler icon, which is in the lower right corner of the map, which measures distances and areas. You can click on that, measure distance, and click to start the point. Double click to end the point when it zoomed in. And here, and this seemed like a very wide part, the flood waters spanned 11.8 kilometers. We can also change that to miles if you want. You can go back here to the ruler icon in the lower right corner and change to miles, but you can also right click on the map with your mouse and change the units as well. So now you can also remove the measurements using that right click. So now that we've looked at this and we figured maybe we want to share this image with our colleagues, let's turn off the place levels first and close the map marker so we can see more of the image. And we will go to this camera icon in the upper right corner that says take a snapshot. It'll open up this bounding box window, which you can adjust by using the corner boxes to the size you want. And then you can take an image snapshot. You can change the resolution of the snapshot. This is the suggested resolution, 250 meters. And you can download it in a variety of formats, so JPEG, PNG, GeoTIFF, and KMZ. You can also add a world file for the JPEG and PNG format so that you can bring them into your own GIS, and then it will be geo-referenced. So if we click download, it should download the image, and then you can just right click and save this onto your computer. So going back to the map, we haven't lost our bounding box yet, but we can close this. And say you also want to share with your colleagues a link to this exact same window with all the layers loaded. We can click on this share map icon in the upper right corner, and then you can copy this whole very long link here, or you can also shorten it. And then you'll have a nice short link which you can copy and paste or send it to someone, and they'll get the exact same map as you had on your computer. Right, going back to here. So we've looked at the image from April 13th. We also went back to April 11th, which was really cloudy. Let's compare this image to a day a month ago. What I'm going to do is turn off the flood layer and then click Start Comparison at the lower bottom part of the layer list on the right side. And what it will do is put April 13th on the left A side and April 6th on the right B side. So I'm going to change the B side by clicking on the B tab to April 13th. So it's the same on both sides. But then for the A side, which is this left side of the map, I'm going to change that to March. In the lower right corner, you can change the dates. So March 13th is a little cloudy, so let's go to March 10th. And here we can see now the big difference between the normal river course and how much of the area has flooded due to the slow-moving storm. It's pretty drastic. We also have in the comparison mode different types of comparisons. So this one's called swipe, where you can swipe to reveal the flooded areas. We also have opacity, which sort of fades between the two images. So B is the flooded side, A is the before image. That's pretty cool. And we also have a spyglass, which is puts the B side inside the circle. So the B side is the flooded area. So you can also compare it that way. If you want to switch it so that the flood is the base image, just click on the B tab and then it'll switch it over. All right, now that we've investigated the before and after, and then the flood product, maybe we want to actually look at this in higher resolution. So let's exit the comparison. And what I'm going to do is remove some of these layers, but I'm going to go to add layers and add one of our 30-meter resolution products, which is called the Harmonized Landsat and Sentinel-2 product. And it's HLS for short. So I will just type HLS in the search bar. And I see that we have two products. So one for the Sentinel-2 satellites, which includes Sentinel-2B and Sentinel-2C. And then the Landsat layer, which includes Landsat 8 and 9. So what it's telling me here is that there is no data available for this day, I think. So what we want to do is look at, find a day that where there is imagery. So while this imagery is in higher resolution, it doesn't cover every part of the globe every day. So there's a trade-off between having high spatial resolution and high temporal resolution. So when you have high spatial resolution, you don't get as many images around the world. So what we're going to use is the available imagery dates option. So go to the View Options menu, and here we're actually querying the database to find out what dates we have for this particular area. Area. Let me see. What I'm looking for is deciding not to work April 8th. And here now we have this higher resolution image on top. So how can you tell it's higher resolution? Now we're zooming in. You can actually see fields. You can see the flood more clearly. that there's some small towns that you can see as well. And this layer that we were looking at previously is the Terra layer, which is 250-meter resolution. So there's a big difference between 250-meter resolution and 30-meter resolution. So now that we've found this, now we'll probably decide that we actually want to download this data so we can bring it into our own GIS. So what we want to do is click on the Data tab in the list here on the left side, so we can download the data. So what we have showing, let me go back and check. I believe we are showing the Sentinel-2 reflectance layer, because if we turn that off, yes, we're showing that here. So go back to the Data tab and select the radio button next to the reflectance Sentinel-2 layer. And what it's telling me is that there are 500 granules available for April 8th. That's for the whole world. We don't want the whole world. We just want this small area. So we can set the area of interest. And this brings up this bounding box that we've seen before. You can, again, adjust the corners of the bounding box. And now we find that there's only 4 granules for this area of the world. So we'll now click on Download via Earth Data Search. It's going to tell you, we're taking you to Earth Data Search. And here we are in Earth Data Search. So it brings up a tour. We don't need to look at that right now. And here are the 4 granules. We can also look at them on the map, which are here. And then this cyan blue box is that box we drew over on the Worldview side. And it shows that we're at the intersection of these 2 or 3 granules. So then you can download these granules to your computer and use them however you might like to use them. All right, we're going to go back to Worldview and close. Click back on the Layers tab. Next thing we're going to look at is we're going to remove these land surface reflectance layers off and zoom out. And maybe now we actually want to see, when did these rains come along? And watch the slow moving storm move across the US. So we're going to go back to the Add Layers button, the red Add Layers button, and go press the back button to return to the category view. And here we are going to add the precipitation rate layer. So I'm going to pick the iMerge precipitation rate, which is rain rate and snow rate in millimeters per hour, and is estimated by the Integrated Multi-Satellite Retrievals for Global Precipitation Mission algorithm. I think I'm going to change to the aqua corrected reflectance layer. And here you can see it, there's a lot of rain on the eastern seaboard. So when I hover on the map, you can see in the left layer list, it's showing you what the rain values are. So the higher, the reds are higher rain rate and the greens are lower. This one also shows snow actually up here, up near Canada. So let's go back a couple of days. You can see the storm moving backwards across the US. And you can move forward again. So say now you think, oh, well, that looks pretty interesting. Let's create an animation of this. So what you can actually do is click on the video camera icon in the lower left corner. And we're going to change the dates to April 1st and to April 8th. Oops, 8. You can type in these boxes. You can also use the up and down arrows. You can actually also pull the arrows here also on the timeline at the bottom of the map. So let's enable the animation to loop and click the play button. And now we can actually see the storm moving across the US and how it lingered quite a bit over the Midwest and southeastern portion of the US. And so perhaps you also want to share this with your colleagues. We can create an animated GIF of this. So we will pause the animation and draw a box around the US. Currently what it's telling me here in red, and this is grayed out, that the image is too big. There's a limitation of how big of an image you can download. So let's coarsen the resolution to 5 kilometers, and then you can click Create GIF. And it'll request the imagery on the back end. And here we have an animation that has the timestamps in the bottom lower left corner, and you can then download this to your computer and share it however you might like. All right, so let's close that, and that is it for this this demo. I had also created a Worldview image of the week about this that you can also explore a bit more yourself if you want to look at the use cases we discussed just now. All right, moving on to the next demo. We're going to look at the Iceberg A63A that grounded near South Georgia Island in March. The Iceberg A63A calved from the Filchner ice shelf in 1986, which is almost 40 years ago. It actually was grounded in the Weddell Sea for over 30 years and has been drifting in the Southern Ocean since 2020. It's currently the world's largest and oldest iceberg, but it has now run aground on the continental shelf surrounding the subantarctic island of South Georgia. It's roughly the size of Rhode Island, with an area of approximately 3,000 square kilometers. So let's go look at this iceberg in Worldview. So in Worldview, you can also look at different map projections. So we have a globe icon in the upper right corner. If you click on it, you can choose between Arctic, geographic, and Antarctic. In this case, we're looking at an iceberg in the Antarctic. And this is what the image looks like today. Firstly, not all the imagery has been collected because the satellite hasn't passed over the whole Earth, as we mentioned before. But you can also see there's a big gap in the middle. And that's because it's currently winter in this region, and the lack of sunshine prevents us from being able to retrieve a reflectance image. There are other layers you can add where you will be able to see imagery, but we're not going to look at those today. So let's go to the events tab. So the events are curated by the Earth Observatory's Natural Event Tracker. And it shows all these icebergs all around Antarctica. The one we're looking for is A23A, which is here up near this tiny little island in the corner, upper left corner. Let's click on the iceberg icon, and the map will zoom to the area and change the date to the latest observation date from this database. So this database has 2025, February 28th as the latest date of viewing the iceberg. It hasn't moved since then because it grounded near the island. So we can also look at different dates related to this iceberg. Let's click on January 31st. And see it a little bit more clearly. You can also click on the dots on the iceberg track line. And actually, if you zoom out, you'll be able to see where the iceberg originated, just down here somewhere, and the path it took over those many, many years. So we also have a worldview image of the week about this iceberg. And here I am going to show you, so you can see the iceberg here in this false color image as well, near the island, the South Georgia island. But also what we can do is look at a bathymetry layer on the left side compared to the iceberg on the right side. So what we're going to do, open in Worldview so we can see it more clearly. So this bathymetry layer shows shallower waters around the island. So this lighter blue color is shallower, the darker blue is deeper. So if you actually look and see the iceberg in relation to the continental shelf, that's what this is. And see it's actually run aground. Can't see it very well, so let's try the opacity, which works a bit better. So here you can see the iceberg, and right here you can see kind of actually, like, if you can see it clearly, there's the iceberg outline and the continental shelf underneath. So it's definitely stuck there now because icebergs are actually quite deep, also quite tall, so they're stuck against this shallower part of the seabed, the seafloor. That's pretty cool there. All right, and now we're moving on to the last example, which is smog over Pakistan. So I have another worldview image of the week where we have embedded worldview onto this website looking at smog over Pakistan. So back in November, we heard reports of very high aerosol index and bad air quality over Pakistan. So here we have this aerosol index layer showing shades of yellow to red, where red is very high values of aerosol index. And that is near the second largest city in Pakistan, Lahore. An aerosol index that you see the values are around 4.3, around 4.3. So when they're approaching 5, it indicates heavy concentrations of aerosols, which could reduce visibility or impact human health. These can be due to dust storms or also biomass burning smoke located in the lower troposphere. In this map, we also have what we have are these AeroNet sites, which are these dots on the maps, these red dots over here near some cities. AeroNet is a federation of ground-based remote sensing aerosol network sites. So if we actually click on a dot, we can see that the reading at this particular dot is 4.19, which is quite high for aerosol optical depth. Values that are greater than 3 indicate that aerosols have become so dense that the sun is obscured and will affect human health, especially for people with asthma and respiratory illnesses. So we can see that the ground-based observation from this ground-based site is in agreement with the satellite observation. If you also want to, you can click on the name on the attribute for the site. Oh, and it should open a picture of where the site is, but it's not working right now. But you can also click on View More Data and look at a chart of how the aerosol optical depth varies over time. So we might wonder, what could be the cause of these high aerosol index values? So let's open it in Worldview and add some other information. So we can click on this, open this Worldview map in a new tab on the embedded map in the upper right corner. And it'll open the map right here and show exactly the same thing as we were showing on that embedded map. And let's add a fires layer. So we'll click on the Add Layers tab. We'll go to Fires and add Fires and Thermal Anomalies. So right now we're showing the Suomi NPP aerosol index. So let's also pick the same satellite, Suomi NPP. This is a different instrument. It's the Visible Infrared Imaging Radiometer Suite. But this is where we can get fire information from. So now we've loaded up the fires, and you can see there's quite a lot of these red fire points located on the map. But let's also turn off the aerosol index layer. And now we can actually see that this is all smoke. In the true color image, you can see it's very shrouded in smoke, and it's probably due to the fires. Right here, this is actually a cloud in the middle, but also we are up against the Himalayas, and you can actually see snow on the mountaintops as well. So typically air pollution in this area is high during these winter months. So this is November, due to agricultural stubble burning, but also coal-fired power plants, brick kilns, traffic. But there's also a reduction in the prevailing winds, and then the colder, drier air also traps the pollution near the surface, and the mountains also help trap it near the surface as well. So I've shown a few examples of Worldview being embedded onto a web page. So this is actually a web page on the Earth Data website. So if you would also like to do this, you'll have to send us an email at earthdata-support@nasa.gov with a short description of your website, and we'll have to put it through an approval process before we can whitelist your domain. We unfortunately can't let everyone embed Worldview onto their website. That's just a restriction we have. I'll provide some resources on that with the helpful links slide on the presentation. So let's move back to the presentation. We'll have just a few more slides to go through. So quickly, we'll go over features in beta testing. We have a charting tool. The charting tool provides the option to create a line chart for a date range, showing change over time and statistics, and also statistics for a single date. It includes median, mean, minimum, maximum, and standard deviation for your area of interest. To note, it's aimed for initial basic exploratory purposes, as it's based on imagery values and not the full precision data. So you have to take the results just for exploratory purposes, but don't publish the data in a scientific journal or something like that. To note, it is still a work in progress, so we have some issues maybe with whether the charts work all the time. We're still working on making user interface updates. But it works with layers that have color palettes, just like the aerosol index layer we looked at just now and precipitation rate that we looked at earlier. And it's currently only available for daily layers. So this example here is aerosol index over the Sahara. Let me add that. Click on that link. And here we're looking at my aerosol index over this area in Africa. And we are actually showing April 7th, and here April 7th has the highest value over the span of these 10 days. So I didn't explain how to get to charting. So charting was actually over here in the lower left corner of the layer list. So you click on Start Charting. It'll give you a small description of how to use it. Let's close that. And then you can draw your bounding box and generate a chart. You can change the date also in this, click on, sorry, there's that chart, but click on this date to change the date selection. You can also pick one single date. So let's say we want to show what we're showing right here, April 7th, and get the statistics for that date. And here we have the max is 4.25 and some other values for this area of interest. All right, and then we're on to our last few slides. So just some imagery use guidelines. NASA does promote full and open sharing of data, and we encourage publication of imagery from Worldview. When doing so for image captions, please cite it as NASA Worldview and consider including that shortened link to imagery to Worldview to allow others to explore the imagery. For acknowledgement in scientific journals, please use this following citation. You can also find that citation if you click on that share icon in the upper right corner of Worldview, and then the third tab says cite us, and you can actually just copy that text and put it into your scientific journal. Here's a list of helpful links. You will get the slide deck afterwards, so you don't have to rush to copy them right now. But that is my last slide. So please visit us, try it out. You can also contribute back to Worldview because we are an open source application. But if you want to bring that imagery directly into your own web application or GIS client, you can use GIBS. So go to this earthdata.nasa.gov/GIBS to find a link to the API documentation. Thank you very much. And that is it.
All right. Well, great. Thank you, Minnie. And so at this point, I'm going to open up the final optional poll, and we're going to jump straight into the question and answer session. So we've had quite a few questions, and it'll be our intent to try to get to all of these questions during the time allotted. We're running a little bit short on time, I would say. So I wanted to first pull up some of the questions that were posed in the chat that may not have been also posed in the Q&A here. Now let me take a look at this actually. I think everybody did add them to the Q&A. Let me just scroll through really quickly. Okay, why don't I go ahead and start with the Q&A here. So the first question is there a general rule of thumb for what size event, flood or fire, can be detected by satellites? For example, I imagine flooding and, sorry, there's a, excuse me for a minute. When there's a new question,
oh, I see it.
The blocks the view. Yeah, so for example, I imagine flooding in a small creek wouldn't be detected. Now, I did provide a initial response that perhaps the Opera surface water extent product could be used, that it can be used for smaller water bodies, but I don't know if Minnie, if you wanted to add anything to this at all.
No, I think that is a good example. So the example I showed for flooding, when we looked at it at 250-meter resolution, yes, you're right. You wouldn't see it in a small creek.
Yes.
The dynamic surface water extent layer is at 30 meters, so maybe possible. It depends on how small your creek is, but it still has to be large-ish, I would say. As for fires, I wouldn't say there's a general rule of thumb, but they do have to be, I think, under ideal conditions, at least, if I remember correctly, 50 square meters in size. But don't hold me on that because I can't quite remember off the top of my head.
Okay. All right. Well, thank you, Minnie. And so let's see here. So the next question is, can I determine the tectonic changes through Worldview?
Currently, we do not have any tectonic related information. We are soon getting Sentinel-1 Sentinel-1 data from the synthetic aperture radar. And this will show surface displacement, but it's not yet available. But it's something that we will be adding sometime in the next year or two.
Okay, and since a couple of these questions were asked initially pretty early on in the chat, but then added to the Q&A later, I'm going to jump to those next. Can I download daily rainfall data for Trinidad and Tobago for various locations in lat and longitude?
You should be able to do that through Earth Data Search. And I don't know if Jennifer, you
And
know.
I did, yeah, I did. So I provided some information about a specific iMerge product that could be used for that purpose, and happy to follow up offline with this participant if that would be valuable. I can add my email a little bit later to the chat. Okay, so the next question, and I'm only going to this now because again, it was asked pretty early on in the chat. Are there any restrictions for using the API in our application?
There are currently no restrictions, but if you do want to download like a lot of imagery, we just ask you guys let us know so that our servers don't come crashing down. So you can email us at that email address over here, earthdata-support@nasa.gov, and let us know. And actually, I can also bring up the API documentation we do have somewhere in here. We do state that if you do want to download a lot of data imagery, that you just contact us. So this is the API documentation page, and you can access via the different APIs.
All right, excellent. Thanks, Minnie. And again, I'm going to go back to one of the questions asked pretty early on. Do you have the ability to identify water depths in flooded areas?
We do not have that ability. That would be really cool. Unfortunately, we don't.
Thank you, Minnie. And let me hop back to the Q&A here. Okay. When using Worldview, I sometimes see solar panels on solar farms showing up as heat anomalies when I'm looking for fires. Is this because the solar panels are hotter than the surrounding land, or is it because of reflectance from the panels?
That's a great question. I don't actually know why it does show up at fires. I'm guessing the algorithm just detects it as that. One thing is, if you do, I saw someone earlier mention that they said Worldview is very similar to FIRMS, which it is. FIRMS actually has an experimental product that shows you static fire points. So it will show you solar panels. So I believe you have to go into experimental mode, if I remember correctly, and it's the static thermal anomalies. Not that one. Yeah, or it actually shows like different things, like different kinds of steel plants, and I think it will have solar panels. Sorry, I have not looked at this recently, but there's industrial plants, power plants. I don't think they have the solar panels yet, but they will in the future.
All right, well, thanks again, Minnie. And then the next question is, could you indicate to me the best products for high resolution imagery? And the example here is 10 meter, 2 meter, 1 meter. I just want to say one thing before Minnie responds. We really don't serve up imagery at that high of a resolution on NASA Worldview, but I can include in the Q&A a link to the NASA's commercial satellite data acquisition program for you to explore some of the options and potential opportunities for data that's that high of a resolution. But Minnie, if you wanted to add to that at all.
Oh, I think you pretty much answered the question. In Worldview, the highest resolution we have is 30 meters, so we don't have anything higher than that. So as Jennifer mentioned, the commercial small sat acquisition program could be helpful. Otherwise, you would have to contact the commercial agencies themselves, commercial companies.
Yes. All right. Well, thanks, Minnie. Okay. So our next question is, let's see, I'm trying to skip by the ones that I have provided a typed response to. Are there any data of aerosol optical depth from Sentinel and Tropomi to compare with ground-based observation?
We are in the process of bringing Tropomi in. So I can't remember exactly what it'll be this year, but I can't remember when exactly. So you'll have to tune back in, or I can reach back out to you when we have it ready.
All right, perfect. Thank you, Minnie. And it might be that you can, in the meantime, access that data. I believe you can access that through the Giovanni system, and I can provide more information in the chat a little bit later, but I want to keep moving with this and I'll come back to it. Okay, so the next question is, when you download screenshots from Worldview, let me scroll down just a bit, do you also have an image timestamp when the satellite image was taken? If not, do you have any recommendation to save and file images so that they make sense in a local shared archive?
That's a great question. And you're right. It doesn't save the timestamp, and that definitely would be very helpful. Do I have a recommendation? I guess if you wanted to do it programmatically, I think you would have to access the GIBS API and perhaps write a script to pull it. Will that give you the time of acquisition? Oh, that's a good question. I'm not sure we do. Maybe I can reach out to you offline, and if I figure that part out.
Sure, that sounds great, Minnie. And that's a good place for me to just tell everybody that I will be providing the Q&A log in the chat to Minnie. So if we do not get to your question because we've run out of time, she will be able to follow up with you offline. All right, so the next question here is, when using the iMerge product, can you specify a rainfall total or rainfall rate total for a 3 to 4 day period?
No, we just display the daily imagery, so it's not accumulated by dates. I suppose if apparently it currently does not work. If the charting worked for this layer, you could possibly create a chart that shows it over time. Don't have it for this layer, but Giovanni possibly has it.
Yes. And again, that's something I can also put in the chat in a little bit here. Okay, so let's see. Let me continue forward here. I'm just making sure. Okay, so the next question is, again, I'm skipping the questions that have been responded to within the chat or the Q&A. So the charting tool will enable us to look at precipitation intensities over a point or over a period of days.
Oh, I'm sorry. Could you repeat that question?
Sure, absolutely. So the charting tool will enable us to look at precipitation intensities over a point over a period of days.
Not for a point. It has to be a bounding box. It currently doesn't work for points. That's another thing that we wanted to include, but it does not work at the moment.
All right, well, thank you, Minnie. And the next question is, are you planning to include river water level or lake water levels from SWOT or Sentinel?
Hopefully we will get SWOT in. That is also on our list of data products to bring in. We don't have it yet, but it's being prioritized.
All right, well, thanks, Minnie. And so the next question is a great question and has to do with the use of Worldview with the NASA Space Apps Challenge. All right, so an unusual question, please. Will NASA be available to immediately whitelist websites of participants in the NASA Space Apps Challenge for display of Worldview results? This is a fantastic tool for non-technical participants in the hackathon, and I agree wholeheartedly.
Yeah, that is a great question because we did not anticipate this the last Space Apps Challenge, and we had a few people ask us for access, and we were not working over the weekend, so we didn't even see the requests. So I think, I mean, I can't say yes right away, but you know, I think we can definitely think about this and see if we can do that for the weekend of the Space Apps Challenge. I don't remember when it's coming up, but we should definitely keep that in mind.
All right, great. Thanks, Minnie. So the next question is there a satellite that goes through East Africa that provides near real-time info like GOES? GOES does not cover the East and South Africa.
There is, but we don't have that in Worldview currently. So I believe it's Meteosat MSG that covers Africa and Europe. We currently don't have access to that data set, so we can't pull it in. It's something we're looking into, but I'm not sure when we're going to get that in.
All right, well, thanks, Minnie. Let's see here. Just trying to make sure I haven't missed something. There are quite a few additional questions here. Let me scroll back down. If I have missed your question, please know that that is not purposeful. Okay. Okay, can thresholds be set to monitor a specific area, then get alerted when those thresholds are met, perhaps with an Earth data login?
Oh, that's a great question. We are currently not hooked up to Earth data login. Like that would be great if we have some kind of alerting system. We currently don't have it. Is this for, let me see, are you talking about precipitation perhaps?
This is a follow-up from Dave
Yes.
Jones. Yes.
Yes. I do see it. Yeah, so we can't do that right now, but that's something we can put on our future desires to add to Worldview.
All right. Let's see here. I think we have captured, I was just looking back up the chat as well to make sure I haven't missed anything. Let me just look here. I do have a couple of questions in the chat. We probably only have time for a couple more. It depends. Okay, let me, I have more space. Okay, is it possible, oh goodness. Okay. What types of data are available to download temperature of different places?
We do have land surface temperature layers. So you can either type in land surface temperature or look at land surface temperatures. There's also probably an air temperature layer, which will be slightly different. Surface air temperature. So you can access that kind of information. It's on a coarser level. This layer is 450 kilometer resolution. That's quite coarse. So it's better for more regional studies than a more local study. I think the land surface temperature layer, temperature would be higher resolution, but that's still 1 kilometer. So you can explore those data sets, data visualizations.
Well, thank you very much, Minnie. And at this point, we have entered, kind of wrapped up our Q&A session for this afternoon. And what we'll do now is we're going to leave the virtual meeting space open for an additional 10 minutes and also to give you time to respond to the polling questions if you're interested. I will try to respond to, and Minnie, if you want to hang on the line, to some of the questions that were asked after 3 o'clock in the chat. And we'll try to get many of those answered. But with that, I'd like to thank our speaker, Minnie Wong, for her time this afternoon. And I'd like to thank all of you for taking time out of your day to join us for this data training event. And thank you so much, everybody. With that, we'll log off from the audio component and leave the virtual meeting space open.
Great. Thank you, everyone.
Thanks, everybody. Take care. Goodbye now.